So this is a question. The question is, which molecule contain only single covalent bonds? Now, how to check which molecule contains single covalent bond? For that, we have to draw the structure. I will draw the structure of for all. First, I will draw the structure of chlorine. Chlorine belongs to group 7. So how many it will share? Chlorine belongs to group 7. How many electrons it should share? A group 7 element. So it will share 1 electron. That's right. When we say share electron, you should not mention the charge +1 or -1. You should mention the number only, because sharing of electron does not have any sign. It is a number, so it will share 1. So what we draw? We have to draw chlorine Cl2. So we'll draw 1 chlorine, then we draw the second chlorine. Covalent bond can be single, can be double, it can be triple. If there is a pair of electron, we call that a single covalent bond. I will give an example here. You will see all the examples. So each chlorine share 1. So this chlorine share 1, the other chlorine will also share 1. How many unshared electron will be there? How many electrons will be unshared? If it is sharing 1, unshared will be? Chlorine belongs to group 7. So out of 7, it is sharing 1, unshared will be 6. That's right. So we'll draw unshared 6 electron, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So when there is a pair of electron, what we call this? We call that as a single covalent bond. Sorry. So this is a single covalent bond. So this is a single covalent bond. So in chlorine Cl2, there is a single covalent bond. A will be the answer. But why not B, C or D? I will give a reason why it's not B, C or D. The single covalent bond means when 2 electrons are shared between the atoms. When there are 2 electrons between the atoms can be identical, the atoms can be different. That does not make difference to single covalent bond. So in this example, but why not B? Why B is not the right answer? I will draw the structure. Carbon belongs to group 4. So it will share 4 electrons. And oxygen belongs to group 6. And it will share 2 electrons. So if we want to draw the structure of carbon dioxide, because the carbon is sharing the maximum number, so carbon should be there at the center and surrounded by oxygen. Then we start the sharing, which are the neighbors, the surrounding atoms. So oxygen is sharing 2. So if this oxygen share 2, carbon will share 2. The other oxygen will share 2, carbon will also share 2. An unshared electron, because oxygen belongs to group 6. So there will be 4 unshared electron on each oxygen. Now you can see there are pairs of 2 pairs are present, or 4 electrons are there. So each pair is represented by a single line. So if 2 pairs are there, they are represented by a double line. So when there is a double line, how oxygen will share 2 electrons? Oxygen belongs to group 6. Oxygen belongs to group 6. So when element belongs to group 6, it will share 2 electrons. So if oxygen share 2 electron, carbon from that side is sharing 2. And other oxygen is sharing 2, so carbon from that side sharing 2. So total number of electron which carbon share 4, and total number of electrons which each oxygen share, that's 2. So when you have two pairs of electron, what we call this type of bonding, this type of covalent bond, we call that as a double covalent bond. Is it clear? The second example, carbon dioxide. Because the carbon dioxide CO2 is having a double covalent bond, that's why it is not the right answer. Abdullah, each oxygen belongs to group 6. So what does it mean? Each oxygen should share 2. Not all the total oxygen should share 2. Each oxygen. This is for each oxygen. One oxygen should share 2 electrons. So that's why this is the oxygen. It shared 2 electrons from the left hand side. And the other oxygen also share 2 electrons from the right hand side. So total number of electron with each oxygen, this is always for each atom. Is it clear? Then about the nitrogen, why N2 is not the right answer? So when we check for nitrogen, nitrogen belongs to group 5. So as it belongs to group 5, it will share 3 electrons. And N2 means 2 nitrogen. So this is 1 nitrogen and this is another nitrogen. And this is for each nitrogen, that each nitrogen should share 3. So if this nitrogen share 3 electron, 1, 2, 3, the other will also share 3 electrons from that side. And how many unshared will be there? Because there are 5. Because there are 5 electrons, 3 are shared. So unshared will be 2. In exam, you have to draw the structure for each. When you are in practice, you can do this in a very short time. So there are 3 pairs of electron. When 3 pairs of electron, each pair is represented by a single line. So 3 pairs represented by 3 lines. So we call this as a triple covalent bond. So nitrogen N2 is having a triple covalent bond. That's why this is not the right answer. What about option D? Oxygen belongs to group 6. So each oxygen will share 2 electrons. Left hand side oxygen bring 2, right hand side will also bring 2, and unshared will be 4. So when we draw the structure, this is a structure of oxygen because there are 2 pairs of electron between the atoms. So oxygen means O2, and what we call this bond, we call that as a double covalent bond. Is it clear? The difference between a single covalent, a double covalent, and a triple covalent bond. So that's why A is the right answer in exam, because to know the right answer, you should draw the structure for each. So option A is the right answer for this. In the question, they're asking what is the total number of electrons in one molecule of ammonia. How to find? They're not asking for shared or unshared, they're asking total number. So we have nitrogen. When you check the periodic table, it is written 7 and 14. So nitrogen is having 7 electron. And when you check hydrogen, it is having 1 electron. So each nitrogen is having 7 electrons. Each hydrogen is having 1 electron, but how many hydrogens are there? 3. So this will be 1 multiplied by 3. So what is the total number of electrons present in NH3? So it will be 10 electrons. So what will be the right answer? So C will be the right answer. Is it clear, this option? Because they're asking the total number of electrons in one molecule of ammonia. But sometimes they change the question. Sometimes what they ask, total number of, example, if I change the question, total number of unshared electrons in one molecule of ammonia. So for in that case, I have to draw the structure, because without drawing the structure, I cannot identify. So nitrogen belongs to group 5. So it will share 3 electrons. And hydrogen belongs to group, like it is not specified, but it will always share 1 electron. So we'll draw structure of ammonia NH3, nitrogen surrounded by hydrogen. Each hydrogen share 1, so nitrogen will share 1. Then the circle for each atom. Then nitrogen belongs to group 5, so it is sharing, out of 5 it is sharing 3. So unshared will be 2. So if the options, what could be the right answer? So if the options were 1, 2, 3, 4. So what could be the right answer? So in that case, how many unshared electrons are there? Only unshared are present on the nitrogen. That is why it will be B. But if I change, yeah, that's right, B will be the right answer. But if I further change the question, I say, what is the total number of shared electron? And the options are also changed now. What is the right answer? Total number of shared electrons. A, B, C or D? So in that case, A or 6 will be the right answer. Because this is 2, 4 and 6. But in the question, they did not ask, because question can change. In the question, they ask for total number. So for total number, we know how many electrons are there in nitrogen and how many electrons are there in hydrogen. So we can work out the total number as well. So question can change depending on, so your option can change according to the question depending on how they are asking the question. So according to the full question, total number of electrons, 10 or C will be the right answer. In the question, which diagram shows the outer shell arrangement in a molecule of methanol? So how you will work out? Simply you will check carbon belongs to group 4. The carbon, it belongs to group 4. So it should share 4 electron and there should be no unshared electron. Hydrogen will share 1 and oxygen belongs to group 6. So it will share 2 electrons and unshared on the oxygen will be 4. Now we'll check the options. Now let's check the options. If you check option A, So when we check the option A, first thing, carbon belongs to group 4, so carbon should share 4. So this is 1, 2, 3. But you can see the fourth electron, the carbon electron, they are representing by a dot. So this carbon share 1, 2, 3, and this carbon share 4. And there should be no unshared electron, so carbon is right. What about hydrogen? Hydrogen share 1. So this hydrogen is sharing 1. This is also sharing 1. This is also sharing 1. And the other hydrogen is also sharing 1. So hydrogen is also correct. What about oxygen? Oxygen should share 2. So one from left hand side and one from right hand side. It is sharing 2 electrons. So that's also correct. And unshared should be 4. So this is 2 and plus 2, 4. So this A is the right answer. Each hydrogen, Abdullah, when we talk about each, not the total number. When I say this is a term which is used for each, that each hydrogen should share 1. It can be 5 hydrogen, 10 hydrogens, but each hydrogen should share 1 electron. So that's why A is a right answer. Why A is the right answer? Because when you check the carbon, it should share 4 and unshared should be 0. For hydrogen, it should share 1 and unshared will be 0. And for oxygen, it should share 2 as it belongs to group 6 and unshared will be 4. Now, when we check so A is the right answer. Why not B? So when you check option B, this carbon is sharing 1. Or you can start with hydrogen. So hydrogen is sharing 1. That's right. Carbon is sharing, or oxygen is sharing 2. So 1 and 2. And carbon is sharing 4. 1, 2, 3 and 4. But why it is wrong? Because the missing electron, there should be 4 unshared electron on oxygen. That is missing. That's why B cannot be a right answer. What about C? When you check C, hydrogen is sharing 1. Each hydrogen share 1. Each oxygen should share 2. So this is 1, 2. But there's another third one is also there. Because of this extra third one, that's why C is not the right answer. And same thing, when you check the last one, they just draw 1 electron. They did not draw the electron for carbon. So that's why this is totally wrong. Because whenever the sharing electron is there, there should be a pair of electron or pairs of electron. You cannot have only 1 electron here. That's why this diagram is totally wrong. Is it clear why A is the right answer? To everyone? Yeah, it is a bit confusing because in the figure they show you carbon and oxygen electron with the same symbol. That's why it might be a confusing, but you have to sort it out according to the structure. If this was another symbol, then it will be much more easier to recognize. But they want to make a difficult question. That's why they use the same symbol for electrons of carbon and oxygen. So it's the same question we just did now. So we have to complete this is exam question. Draw a dot and cross diagram to show electron arrangement in a molecule of methanol and show the outer shell electron. So when you check hydrogen, each hydrogen will share 1. Oxygen belongs to group 6, so it will share 2. And unshared will be 4. And carbon belongs to group 4, so it will share 4 electron and there will be no unshared. So you can start this figure. If I start with carbon, say hydrogen, so if hydrogen share 1, carbon share 1. Hydrogen share 1, carbon share 1. Hydrogen share 1, carbon share 1. Hydrogen share 1. Then this is oxygen, so I should use a different symbol. So I use a circle here instead of dot. Then each oxygen will share 2 electrons. One is already shared on the left hand side. Oxygen share 1, carbon will share 1 from that side. And now the unshared electron of oxygen, there should be 4 unshared. So 1, 2, 3, 4. So this is a structure of methanol. Is it clear? In which we have to just show the outer shell electrons. Most of the time the circles are given and you just have to put the electron which are shared and unshared. So that makes it easy to solve the question. Okay, another question, the structure question. NH3 has a covalent bonds. What is covalent? What is the definition of a covalent bond? And it's of 2 marks. So the definition, a bond is formed between the 2 atoms by sharing of electron. So when the bond is formed between the 2 atoms by sharing of electron, what we call, yes, you can use the term non-metal or 2 atoms, you can also mention. What is the mark distribution? You can see M1. M1 means first mark. So if you use the term shared electrons, so I use the term sharing of electrons, shared electron, I will get 1. Or a pair of electron is shared between the atoms. We'll also get the second one. So a shared pair of electron or a bond is formed by sharing a pair of electron, that's called a covalent bond. Then we have to complete a dot and cross diagram for NF3. So we have to check the group. Nitrogen belongs to group 5. How many it will share? Nitrogen belongs to group 5. How many it will share? So it will share 3. And how many unshared will be there? Out of 5 it is sharing 3. So unshared will be 2. Fluorine belongs to group 7. How many it will share? That's 1. And how many unshared will be there? That's 6. So now we'll draw the structure. If fluorine bring 1 electron, nitrogen should bring 1 electron from that side. Fluorine bring 1 because each fluorine share 1. So if each fluorine share 1, nitrogen will share 1. Then the unshared electron, for fluorine we have to draw 6 unshared. So how to draw 6? Unshared 1, 2, 3, 4, 5, 6. Same thing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And for nitrogen, only a pair of electron or 2 electrons are unshared. So this is the actual structure of NF3. And you can see what is the mark distribution. 3 correct bonding pair. So if we show the bonding pair 1, 2 and 3, we'll get 1 mark. Then we should show a non-bonding pair for fluorine. Like we should show these non-bonding electrons. For fluorine, we'll get the second mark for all the fluorine. And the last mark, a non-bonding pair for nitrogen. That will give us the third mark. Is it clear? This example of NF3. If one element you are using a dot, the other one should be a cross. Don't use the same symbols. otherwise you will be confused. And they already mentioned use a dot and cross diagram, so one should be dot, the other should be cross. Then carbon dioxide, a molecule carbon dioxide, carbon belongs to group 4. So how many it will share as it belongs to group 4? Carbon belongs to group 4. How many it will share? And how many unshared will be there? 0. Oxygen belongs to group 6. How many it will share? 2. And how many unshared will be there? 4. So now we start with a neighboring one. If oxygen bring 2, carbon will also bring 2. If oxygen bring 2 electron, carbon will bring 2. So oxygen sharing is done, carbon sharing is also done. Now the unshared of oxygen, there are 4 unshared, and there is no unshared for carbon. So this is a covalent bond between carbon and oxygen. Is it clear, the structure of carbon dioxide molecule CO2? So these are the examples related to covalent bonding. Then a covalent compound can be refers to a simple covalent or it can be refers to a giant covalent. What is the meaning of a simple covalent? Simple covalent means when we have finite number of atoms or we have fixed number of atoms. In the structure. But when we have infinite number of atoms or we have uncountable number of atoms in the structure, we call that as a giant covalent substance. Example, a simple example, when I say H2O, so H2O or water, when you draw the structure, you have hydrogen, you have oxygen and hydrogen. So you have finite number of atoms, like you have in a molecule, in one molecule, you have 2 hydrogen and 1 oxygen. So when we have finite number of atoms in the structure, we call that structure as a simple covalent structure, or we call that as a compound as a simple covalent compound. But there are also giant covalent compounds. What is the meaning of giant covalent? It means we have so many atoms in the structure. Example like sand, which is having a chemical name silicon 4 oxide. This is a name, chemical name of a sand, also known as silicon 4 oxide. What happened in a sand? It is a giant structure like silicon attached with oxygen. then another silicon, then so many oxygen, then silicon, oxygen, and it continue like we have infinite, so many atoms are there, we cannot fix the number of atoms and it continue. So when we have too many atoms in the structure, what we call that, we call that as a giant covalent structure, also known as macromolecule. Is it clear the concept, the difference between a giant and a simple? Like the giant structure means when you have lot of atoms in the structure, infinite number of atoms in the structure, we call that as, no, this 4 is only representing, Abdullah, this 4 is representing that silicon is sharing 4 electron, but it is not showing how many silicon atoms are there. There are lot of silicon atoms and lot of oxygen atoms in the structure, uncountable atoms in the structure. That's why we call that as a giant. But in case of water, water is a simple covalent. Why? Because when we draw the structure of water, there is always 2 hydrogen and 1 oxygen. So it is called a simple structure or a finite structure. So tomorrow we will discuss the giant or the macromolecules, and 3 macromolecules structure. Basically you have to memorize or learn their structure. The 3 of them which we will discuss tomorrow, that is diamond, graphite, and silicon oxide or sand, that we will discuss. There are many giant macromolecular structure, but for your course you have to learn only 3 of them, which are diamond, graphite, and sand. Is it clear? That is a chemical name, silicon 4 oxide. When we say silicon 4 oxide, it does not mean 4 silicon are there, it means silicon is sharing 4, and that we will discuss in detail about their structures. Any question related to the class today? So in the first session we discuss first the covalent examples and compare ionic and covalent compounds, and in the second session we discuss questions related to covalent compound. And tomorrow we will do giant covalent structures or giant covalent molecules, also known as macromolecule. So I'll end the session and share this recording with you.